student, I have to learn music history for undergraduate. So at some point, I get to know about Stochastic music, and so my first impression is, okay, mathematical process, a mathematical technique with musical composition. I think the first piece I've heard of him is Ekma. It's a piano piece that involves mathematical set theory instead of the 20th century modern music set theory. And yeah, I start to learn more about his music. I think Stochastics do that as well. For example, in his S709 is one of his charismatic pieces written in the 19th. I think the number there is actually the number of the result that he got from the computer. Yes, I think actually Stochastic open up a lot of research area or possibilities of using computer in music. For example, stochastic procedure, you can use it in a microscopic level. For example, the structure of the piece or structure of the music, or in very microscopic level, this generation of the sound from blank.
Everybody knows Xenakis and his work that he did on stochastic algorithms. And Sergio kind of took that up and kind of extended it in lots of interesting ways. And so, I mean, I think of that as a kind of a particular example of a kind of range of sort of algorithmic approaches for generating sound or music. So this is kind of idea about using algorithms as, to in some way generate or manipulate sound. And that can happen at different levels. With stochastic synthesis, it's happening at a very low level. With other sorts of algorithmic approaches, it can be, it can be up to sort of an event level.
For this piece, actually the sound and the structure of the piece is composed. But I would say it is half improvised because it is actually quite technique demanding, or it is actually quite difficult to do the same thing every time. But it's actually the same on playing an instrument. So yes, you practice a lot, but actually every time when you record it is slightly different. I also think that as a composer or as an artist, I have to make my own judgment. So for that kind of process, I only generate my materials. So I think the most important part is, as a composer, how to choose what from all the result. Yeah, because with a computer or with a single algorithm or a single technique, you can generate a lot of result. And I think if you want to use that in a piece of art or a music, for example, you have to, as a composer, you have the responsibility to choose what you want, choose from the result instead of let the computer do it, or else you lose your privilege or your purpose as a composer, right? Yeah.
So I've been part of BEER since 2014, 2 years now, and what we mainly do is live improvisation with laptop, and so my role is a player here and mainly do improvise stuff. Yeah, and for this concert, I contribute to do the visualization with Scott.
The group has been together for several years now with various members, and the group is focused on, it's a laptop ensemble. We focus specifically on live coding, so we're writing programs which you can modify while they're running, which are producing the sound, and improvising with structures which are usually imposed by some sort of network computer system. So that's the kind of background. This particular project is a project where we're taking data from CERN, from the Large Hadron Collider, specifically from the CMS compact muon solenoid experiment there. We're using that data to sonify, we're sonifying that data, I should say, using it as parameters for synthesis processes which we're running.
He started a few years ago, probably in 2011, with this project. Was more very centered about creating specific algorithm for centralize the creation of music. So we usually are 4 or 5 people playing all together, but all the sounds are centralized by one unique person who is usually the master. That is the thing. In this specific case, it is different because for the reason that we got some really extensive and uncontrollable data from the CERN within the art and Large Hadron Collider project. We are in this moment, we have an incredible amount of data that it is really difficult to handle, and so we have chosen to create specific functions that are shared amongst us performer, but everyone is playing by himself without this centralized option. So there is not a specific master who is saying how things should change, but everyone it is changing the music and the use of data depending of only musical qualities.
What is difficult is that it tends to have a lot of stuff in one particular range and then a few very extreme outliers. You know, so you can imagine that if you were mapping something like that to pitch, you would have, say, a whole bunch of low notes and then the occasional high note that flicks out. So it's interesting to think about that from a musical perspective of how do you do something musical. In June, we're going for a residency in Greece, which is with a place called Medea, which is kind of art center, and also the American College in Athens. And then we hopefully are going to CERN later on in June.
The collaboration between science and art, you got a lot of freedom. So actually you can, for example, you can use any meaningful data to map into music parameter, for example, or any art or shape of it, and physical artwork. You can do anything like that.
It's an interesting time, I think, because we don't have maybe sort of, if you look at it from a stylistic perspective, there isn't like a kind of single dominant style. And I think that's been true in many ways since throughout through the last century, actually, in certainly through the last half of the last century. But I think that different sorts of things became more or less entrenched or more or less supported, and there's certain sorts of music that tended to get done in British universities, for instance, and I think that's still happening. Those things which were in their time perhaps quite experimental and new are now quite established, but they're still there. There's also a kind of opening up to other things and other possibilities.